Yep, was good. So got a quick question for today. Wait, my microphone's not connected. Hopefully it switched microphone. So standard heat of combustion per mole, thermochemistry, etc., etc. So we got the heat of combustions provided, and now we need to find out the heat of hydrogenation of 1,3-butadiene to butane. So we want to probably write that out. So that reaction, actually I forgot to take that part of the question onto here. So we're also provided with this. Okay, so now this is the reaction that we need to create from the three combustion reaction that we're provided with. So you know that a combustion reaction is just plus O2 equals CO2 and H2O. So here we are, we'll do the first one, C4H6 plus O2. We wanted to put I need to balance this stuff. H2O. Okay, so this is going to be gas. This is going to be gas. But this one apparently is liquid. I remember when I did it in class, the prof said it was liquid. I think it's because it's at 25 degrees Celsius, so it's not going to be boiling. So yeah. Okay, so now we need to balance this out. C4, we got 4 carbons. So CHO, carbons, hydrogens, then oxygen. So we got 6 hydrogens on that side. We got 2 hydrogens on this side, so we need 3. Now how many oxygens do we have? We have 8 plus 3, which is 11, but we have O2, so this will just be 11 over 2. And this is going to be negative 2540.2 kilojoules. Okay, 1 done. Okay, now do 2. C4H10 gas, that looks like a 16, plus O2 gas, CO2 plus H2O liquid gas. What is this going to be? So we got 4 carbons, 10 hydrogens on the left, so we got 5 hydrogens on this side. How many oxygens? 5 plus 8, 13, so 13 over 2. Because 13 over 2 multiplied by 2 is equal to 13, and that will be 13 oxygens on both sides. This is negative 2877.6 kilojoules. Okay, now equation 3. H2 plus O2. What are we going to get? Well, there's only one possible thing. Well, I mean, I guess we could get OH, but it's H2O. Liquid. So we have 2 hydrogens on that side. We got 1 oxygen on the right side, so we need 1 over 2 here. And this is going to be negative 285.8 kilojoules. So now we need to make sure these reactions add up to the top reaction that we have. So C4H6, that's on the right side, so we could just go ahead and write that down here. We don't have to manipulate this one in any way, because we have the right products in the right side. Because like we need C4H6 in the reactants, and we have that. So now for 2, we need C4H10 as a product. So we have to flip this equation. So if we flip it, it'll become positive now. Nice. Now what's the last one? We need H2 on the bottom. We need H2 on the left. However, we need 2 H2, so we have to multiply this one by 2. So if we multiply negative 285.8, okay, nice. So now we just gotta make sure these cancel out. So what do we need? So we got this. This is good. 4 CO2. This isn't gonna be. Wait, no, that's not. I'm looking at the wrong one. C4H6. That's good. We got C4H10 here. 4 CO2. These two will cancel out. 3H2O. So we got 3H2O plus 2H2O equals 5. So these will all cancel out. Now the last thing is, okay, so we got 2H2O. This is something we need. Now these oxygens should cancel. So what is 11 over 2 plus 1? That's 13 over 2. Cancel, cancel, cancel. Boom. So that's what we're left with. So now we just got to make the net equation and add these values all up together. So what we should get, let's put it into the calculator. Well, I started from the... Should get a value of negative 234.2 kilojoules. Standard heat reaction. Boom. There you go. That was pretty quick. Yeah, pretty simple question as well, I would say, but just got to make sure to remember to like kind of flip your equations and stuff like that. So yeah, that's pretty much all for today. I'll see you tomorrow. Goodbye.